Thank you very much. Go ahead, then.
Okay, so yeah, sorry for messing you around 5 minutes. So my name's Natalie Webb, and I'm head of the XMM-Newton Survey Science Centre. So for those that are not familiar with the Survey Science Centre, it is a consortium of 10 different institutes in Europe that was chosen by ESA to put together a large part of the science ground segment in collaboration with ESA and also with NASA. And this dates back now 30 years, so it's been in existence for quite a long time. And I'm currently the head of this consortium. So we put together a large part of the SAS that I just to talk to you about. We put together the original pipeline for reducing and analyzing all the data automatically. And we put together also a program to follow up sources that were detected with XMM, and the biggest part of our activity today is producing the different XMM-Newton catalogues, and that's what I'm going to talk about now. So you're probably familiar with catalogues. Most observatories now do provide some kind of catalogue of either detections or sources. So there is a subtlety between the word detection and source. Often we use them interchangeably, but actually there's a real meaning to the two. So a detection is every single time you detect an object. So if you were interested in one particular object, you made 10 observations, you may have 10 detections of that object. So 10 detections of that single source. So source is the object you're interested in, and then detection is each time that you've seen that. So why would you want to use a catalogue? I think there's a lot of good reasons to use a catalogue. Firstly, it really often gives a very quick access to products, so you won't need any specialized knowledge just to be able to get some fluxes of your source, maybe a spectrum, time series, images, all kinds of different edited products, as well as quantities that have already been done, produced by specialists that know what they're doing. Also, because they're often huge resources. I mean, XMM, we've only got a million sources, where there's obviously things like Gaia, where there's 2 billion objects, so that's much bigger. But it's a massive resource to find new objects. They're also very useful for population studies. All of these objects have been reduced and analyzed in the same way. You've got a homogeneous data set, and so you can pull out sets of AGN, you can pull out sets of cataclysmic variables, you can pull out sets of one specific type of star, whatever you want to do, you can pull those out of a catalogue without having to reduce or analyze any data. So that's extremely useful. And they're also very useful for cross-correlating with multi-wavelength studies or even multi-messenger. We'll look at a little bit at that later on, and also during the hands-on session. Obviously, catalogues cover all different kinds of wavelengths and contain a variety of information. I'll give you some insights into what kinds of information are generally available, and then talk more specifically about the catalogues. And catalogues are becoming more and more important. You're probably familiar with the Visier site at Strasbourg. They have a large database of pretty much most catalogues that have been produced for astronomy, and there's now almost 26,000 catalogues that are on that site. So you can see the web link there. I will provide my slides, and these links are clickable. And later on, I've also got some QR codes if you want to flash them at some point. And something as well to remember is that most catalogues are produced in more than one format, so you can usually find a format that works for you. So formats that are pretty frequently used are tabular formats, so something like a FITS file, which you're probably familiar with if you've been reducing Swift data and you're going to reduce XMM data. CSV, so these are comma-separated variables, so it's literally just a text file, and then each one of the variables is separated by a comma. It's not complicated. Or just simple text files, and you can use whatever you want to manipulate those tabular formats. So you can use SQL scripts if that's something you're interested in. If you're used to doing X-ray data, then FTools you might want to use. So FV particularly, you can open and look at your script, your table to start with. If you prefer Microsoft tools, then Excel or something similar will often open many of the different catalogs, especially if they are in something like CSV or text format. There's some excellent dedicated software out there. I'm mentioning here TopCat, and then there's the programming language for TopCat, which is called Stilts, and the little cat that's next door is the logo for TopCat. I mentioned that specifically because we're going to use that later on during the hands-on session, because it provides a very easy way to look at your catalogs. With just one or two little clicks, you can pull out all kinds of parameters, images, light curves, whatever you want. Obviously, you probably want to write your own script. If you've got something very specific you'd like to do, you can write a script in whatever language you prefer, Python, C, IDL, however you want to do that. But obviously, there's many other ways you can use the catalogs. Nowadays, it's becoming more and more frequent to use online tools to both access and visualize the data. And I'll talk a little bit about that as well. We've produced some fantastic tools for visualizing XMM data. Aitor just mentioned to you about ESA Sky. I've not specifically put it in this presentation, but we will talk about it this afternoon when we do the hands-on session. ESA Sky is a fabulous way to access XMM-Newton data and all other kinds of data. We'll look at that later. And then that gives you just complete freedom to do whatever you want with your catalog. So what is inside a catalog? Usually there's a unique identification for each detection, although it could be for each source, depending on the kinds of catalogs that you're interested in. So you're going to have the position of the object that you're interested in. And what is very, very important is the error on that position. This varies dramatically from catalog to catalog, and even for the different catalogs that we have for XMM. The date and time of the observation, and this is very important if you're very interested how your source will vary with time, or how it doesn't vary even with time. And then often, and this is also a very important quantity that people don't always look for, is the quality of the detection. So not all detections are equal. Some detections are very certain, some are less certain, and that's something to be aware of when you're manipulating a catalog. You might have measures of, say, the flux. It could be the rate, the counts, or magnitude, and it can be in just one band or maybe several bands. So they can break up. You could break up energies or wavelengths into different bands. We'll talk again about this later. And then obviously error on these values, and again that's important to take into account. They can also have things like a unique source identification. So if there are many detections, they could be related to one single source. You might have the different products in their spectra. There might be timing products. There might be a measure of the spectrum or the variability. There may be images that you can access directly from the catalog. There can also be, and this is becoming more frequent, a tentative source identification. So depending on the kind of catalog you're interested in, there might be some indication about what that object may be. Things that are also useful, things like observing conditions and other projects that are available. So this is a really busy slide. Like I say, I'm going to provide my slides to you. You'll be able to access all of this information in a calm manner rather than just looking at a really busy slide. So we have at the moment a number of different X-ray catalogs for XMM. And then there's also an optical and a UV catalog. So you saw about the different detectors on XMM. So we have 2 MOS detectors and PN, and those amount to being EPIC. So we have an EPIC detection catalog. So each detection that has been made with time, and the latest version is 4XMM DR14. So this was released last year in July. Usually we make a yearly release of the catalog. However, we're now in the process of making 5XMM, and it's taken a little bit longer than we'd planned, so it's not quite here, but I'll talk about that again later as well. So why 4XMM? Because periodically we have improved calibration and data and pipelines. We re-reduce all of the data from the beginning of the mission. 4XMM relates to the 4th time we did this, and then 5XMM will be a new re-reduction of the data. And the data release then is 14, the next one will be 15. What we also do is we create a stacked catalog. So we take observations of the same fields, and we stack them up, and then we can reach much deeper fluxes, we can get much better statistics on the different sources that are in that catalogue. So that by nature is a source catalogue, but we do provide information about each detection or non-detection. Again, that's released at the same time as the detection catalogue, so the last version was in July 2024. The OM and UV catalogue, you heard about OM, as you've heard about UVOT probably over the last couple of days. So it's a very similar kind of telescope. The last version of this catalogue was back in October 2023, and this is 6.2. And then we also produce a catalogue of the SLUs. So the PN camera stays open as XMM moves from observation to observation. And then we take that data and we can run source detection on those SLUs and produce a catalogue of those sources. It's a much less deep catalogue than you'd get for the detection and the stacked catalogues, because you only fly literally past each one of these sources for a few seconds. We also provide many other products. I'll talk about that. Be aware though, we're trying to improve this and provide a single product that makes it much easier to access all of this information in one go. So we have upper limit servers. There are a number of different ones. There's Flix, Highlight, and Rapid XMM. If you're interested in doing many accesses to upper limits, so this is where a source has been observed but not detected, I'd recommend the Rapid XMM because it uses pre-measured values in a database, but there's much less flexibility in Rapid XMM. So if you want to do source-specific upper limits, I would either use Flix or Highlight. You can access the different value-added products that we've been producing. I'll talk about that a little bit later on. And we're also now making alerts as of the beginning of this year to transients in quasi-real time. So these are alerts for very variable sources that are detected now. And you can see the link to be able to access these transients. Hopefully you're seeing my mouse run across my screen. We have a number of other different servers. You just heard about the XSA from ITOR. We have the SSC web pages where you can find all of the links to catalogs and all these other products. They're all linked from that web page. And then there's an equivalent of something like the XSA and the SSC on the NASA side. So what do we provide in the catalogs? We provide in the detection catalog for 4XMDR14, 336 columns of information. It sounds like a lot, but it's actually much easier to manage than Chandra would have a couple of thousand. We provide identifiers and coordinates, obviously, of our sources, the date, time, and observing mode of each of the ones of the detections, information about the exposure, background information, the extent of a source. Is it a point-like source, or is it an extended source, like maybe a galaxy cluster or supernova remnant? We provide counts, fluxes, and rates, and we provide that in the whole of the XMM band, which is the 0.2 to 12 keV band. But then we break that down into bands 1, 2, 3, 4, and 5, which go from the softest or the lowest energy X-rays up to the hardest X-ray energies. We also provide a measure of the spectrum. These are called hardness ratios. And that's literally band, say, as an example, 2 minus band 1 divided by the sum of the two bands. And so that gives you some information about how your spectrum is varying in those two different bands. And we do that for each of those bands. We provide the maximum likelihood. So this is the measure of the goodness of the detection. Quality flags, which is also very important. We'll talk more about that in the hands-on session, but it gives you an idea of how reliable a source is. And we also give some information about the variability of the sources. So you can see here the projection of this catalogue on the sky. This is a hammer rate of projection. So the center of the galaxy is in the center of the image, the plane of the galaxy along the central line, and then the rest of the universe around the edge. So the most recent version of this catalogue has got about 1 million detections. We provide spectra and light curve for the top 36%, so the ones with the most counts. In this version of the catalogue, you need 100 counts to provide a spectrum or a light curve. And some of these sources have been detected up to 90 times. Moving on to the stacked catalogue, we have very similar information, except we've taken all the data and stacked it up. So there's some specific information there as well. So we have 349 columns, but we also add variability per band. We provide the number of exposures per source, and also for the source detection. And we also provide image coordinates because they need the sources need to be transferred into image coordinates to be able to stack. So you can see immediately the interest of stacking your data in this plot here. You can see a single observation on the top left, and on the bottom left, you can see we've taken 31 observations, and you can see many, many more sources. You can see the source detection has been run on the right-hand side, and there are many, many more sources if you stack up your observations, and each one of those sources has got many, many more photons. And we find about 16% new sources with respect to the DR14 catalogue. I'm going through this very quickly. I'm sorry if there's a lot of information to absorb. So we provide our catalogues in FITS and CSV versions. We provide, as I mentioned, spectra and light curves. We also provide images and multi-wavelength counterparts. We provide scripts if you want to read your catalogue using an SQL script. Those are provided on the XMM SSE web pages, which you can see the link here in the bottom of the slide. We provide a list of all the observations in FITS or text format, so you know what's in the catalogue. We provide multi-order coverage maps per observation and also for the whole catalogue. Flux maps in counts and rates for each observation. Spectral energy distribution, so this is taking the X-rays, but also all other fluxes we can find in radio all the way up to gamma. As I mentioned, we provide upper limit server provides you the upper limits for where there is no detection. User guides on these web pages, very, very detailed. Obviously, understand you probably don't want to read all, but the information's out there. And the other products that are present in the XMM-Newton Science Archive and on our XMM SSE catalog server. So these are the different places you can find that information. This on the left-hand side is the XMM SSE web pages with the different access to the different catalogs and the different tools that we provide. It's not very up-to-date image, sorry about that. This is the XMM catalog. You can access all the data products. You can fit your own spectra within this tool or extract light curves on the fly in this tool as well. We'll talk about these later on. This is the XCatDB in Strasbourg. Again, access to all different kinds of observations. This is the NASA HESARC website, and this I just mentioned to you, the XMM Science Archive. This is what the upper limit server that we provide looks like. So you enter your coordinates to estimate the sensitivity, or you can just upload a file with a list of the coordinates you're interested in. And this is what it will look like for a simple observation. Your source non-detection is here, the region you've chosen to detect in. You get information about MOS1, MOS2, PN. There's also the stat catalog information that's in here. And if there are many observations of your source, there will be one for each one of those observations. You've got the average detection threshold, taking into account all observations as well. So I mentioned we provide the SLU catalog. We provide a catalog with 99 columns of information. We only use 2 bands for this because there are many fewer photons in each one of the SLU detections. So the 2 bands we provide are between 0.2 and 2 kiloelectron volts and 2 to 12, and obviously the full band that goes from 0.2 to 12. Again, we provide the identifiers, date, time, etc. And then what's very specific for the SLU catalog is that we actually try to make some kind of identification where possible for each one of the different sources. So the SLU catalog is very interesting because we SLU all over the sky, so we actually cover almost the whole sky. This plot is a Hammurabi but the colors relate to the fluxes for each one of these sources. So the darker color indicates brighter sources, which you're obviously finding in your in the galaxy center, in the Magellanic Clouds, etc. And the most recent version of the SLU catalog was released earlier this year in February. And there's about 140,000 detections in there. We also released the OM catalog, as I mentioned. So the OM has got 6 filters, 3 UV filters, UVW2, UVWM1, and then the optical filters UB and V. You can see those different filters in this plot at the bottom right, going from 100 to 800 nanometers. You can see the UV filters here. Obviously, the sensitivity is not as good as for the UB and V filters that you've got. We have 116 columns of information, including fluxes, rates, and the AB magnitudes. Again, quality flags as before, detections in stacked images, and also whether or not fast data exists. Aitor mentioned this. You can take optical photometry in fast mode, and therefore you have many, many detections per observation of your source. So I didn't plot up the catalog, which is called SUS. So the latest version is 6.2, but this is just to give you some idea about the quality of the ultraviolet data. So these are images actually taken directly from the ESA Sky facility. You can see 2 different fields that were observed with OM. So you can see the quality is absolutely excellent. We've got almost 10 million detections in the catalog, which is about 6.7 million sources. And over 1 million of those sources have got multiple observations. So it's a fantastic resource to look at the ultraviolet sky. So I did mention that we're trying to produce a new catalog version called 5XMM. The reason being is that the catalogs, there are many catalogs, and also I think there's more we can do to make your life easier doing science. So things I think you want to know if you look at a region of the sky is, what is the source? What does it look like at other wavelengths? Has it always looked like this, or has it changed in some way? What does the X-ray spectrum look like? How far away is it? Is it in our galaxy or is it extragalactic? And if so, what is its redshift? And can we detect fainter sources than what we're doing? So this one here, can we detect fainter sources? Yes, we've put into place much improved methodology for making the stacks so we can get to deeper values. And we've also been putting together some machine learning to be able to identify sources. So you probably can't see what's on this plot, but basically we've managed to create machine learning that has identified every single source within the catalog now. And those information are going to be present in 5XMM, where you identify AGN, quasars, stars, galactic X-ray binaries, extragalactic X-ray binaries, CVs, etc. We've also fitted all the spectra I mentioned to you before. We're fitting with fairly simple models, though we have some more source-specific models that we've done for the brightest spectra. You can find all of these catalogs. They're currently available, but all of this information will go into 5XMM. So this is the link down at the bottom of this page if you want to access this information now. It's just not in a single catalog yet. We've also made a measure of the redshift using photometric redshifts. So these are the redshifts that we've got, going from 0 up to almost 3 in these plots. As I mentioned, we've got this improved source detection. We've got both the upper limits, and we're now providing, as I mentioned, the alerts for transient sources. And this is the kind of information we'll be providing to you, how a source varies with time and how it varies spectrally. So this is my last slide. So just to let you know, 5XMM, we've reprocessed all the 17,000 observations that are available since the beginning of the mission. We're making a simplified catalog. It'll be a single stacked catalog with 441 columns. So we've tried to limit this to not too many, but we obviously want to provide information to you. So we're going to have the OM data in there with multi-wavelength counterparts. We'll have the upper limits included in the catalogue, long-term variability information on the X-ray and on the OM data, spectral fits, the classifications for each of the objects, and photometric redshifts. And that should be hopefully available in June next year. So I'll stop there. I'm aware I've given you a lot of information, and yeah, then if you've got any questions now, and if not, we'll meet later on for the hands-on session.
The microphone is reducing the noise, but people were uploading, so thank you very much.
Fantastic. Okay, great.
Is there any question now from the room or online? If not, we can probably discuss during the hands-on with Natalie as well. Thank you very much for now, and we are having coffee, I think. We'll reconvene in half an hour, I guess. Okay, thank you very much. Bye. Bye. Bye.